In this video, we'll cover alkene and alkyne nomenclatures. Now, alkene and alkyne refers to double bond and a triple bond, respectively. We also follow the IUPAC nomenclature like the alkanes and the cycloalkanes for alkenes and alkynes. Let's go over a few rules in order to find out how to name alkenes and alkynes. So the very first thing you want to do is name the alkene and alkyne according to the longest continuous chain. So for example, on the left-hand side, we have a double bonded alkene, and on the right, we have a triple bonded alkyne. So we go ahead and number them 1, 2, 3, 4, 5, 6. That long chain right there are 6. So it has to do with hex. But instead of saying hexane, because there's a double bond, we add the suffix hexene. Okay, so instead of ane, we write ene. So for something like this, 1, 2, 3, 4, 5, there are 5 carbons, and instead of pentane, we write pentyne. So let's go ahead and write it. This one would be, the one on the left would be hexene, and the one on the right is pentyne. In addition, we have to locate where this double bond is located and where the triple bond is located within this entire molecule. We're going to go ahead and number them so that the lowest start of the double bond, the start of the double bond or the start of the triple bond, carries the lowest number. So let's go ahead and number this going from left to right and right to left. So if I consider carbon as 1 and then 2, 3, 4, 5, 6, going across this way, same thing, 1, 2, 3, 4, 5. Okay, I'm going across that way. And in reverse direction, I'm going to number it in green. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So let's talk about the hexene. If I were to consider numbering like in the red direction, going 1 through 6, well, the start of the double bond is on carbon number 2. Whereas if I were to go in the other direction, the start of the double bond is on carbon number 4. So we want to find the lowest number location for the start of the double and triple bond. So we consider this as 2 hexene instead of 5. So we would write, let's go ahead and keep the color coordination, 2 hexene. You might find in other textbook, and this is not wrong, it will say hex 2ene. You might find this. Something like this is commonly found in a lot of the organic chemistry books, and it's okay to write it like that as well. However, we are going to keep it like this for the scope of this particular class. So what about pentyne? For pentyne, 1, 2, 3, 4, 5 going in the right direction, and the reverse direction is this way. And the lowest number in which triple bond starts would be this green one. 2 pentyne would be the correct answer. And again, in other textbook, you might see pent2ine. And we're going to keep it as the first one, the most simpler one, okay? In particularly for alkenes, so for double bond, there is an isomer. Isomers they have the same molecular formula, but they just are arranged a little differently. Take a look at this hexene and this hexene. They're both 2-hexene, meaning it's on carbon number 2 and carbon number 2. So it's like the same edges from before, but you'll notice the word cis on the left and trans. That's because it really depends on where the location of that hydrogen is. Here, the location of the hydrogens are below. If you look, kind of stretch out the condensed structure, you see that the hydrogen is below, whereas the trans is across from each other in diagonal. One is on top and one is on the bottom. Well, when the hydrogen is on the same direction, either both below or both top, doesn't matter, that's considered to be a cis 2-hexene. For trans, it must be diagonal, whether one left one is on top and the right one is on the bottom or the other way around. Doesn't matter. The point is it has to be trans. The cis and the trans are applicable for only for alkenes, those one with the double bond. And on top of that, double bond needs to be located towards the middle, not the very end. So it has to be criteria for cis and trans, must have a double bond, have double bond, and the second one is a double bond should be located in the middle. If it's on the edge, like for example, like this, you see the double bond is on the 1. This would be 1-butene. It would not work. It has to be like in the middle right here in order to have the cis and trans stereoisomer. Stereoisomer could apply to even for cyclic alkenes, but we won't go over it. That's beyond the scope of this class. We just want to have an overview of the organic chemistry. If the cyclic structure has a double bond, you're going to write the word cyclo in the front of the parent name. So look at this, 1, 2, 3, 4, 5. So this is a cyclopentene, okay? So this is a cyclopentene. We don't write 1, we don't write 2 or 3, okay? There's no numbering. We just assume that this is where you count off with. That's number 1. And so therefore, this is considered to be cyclopentene. Now let's do a learning check based on what we have learned so far. Here we have a line angle structure, and I'm going to work my way backwards to the IUPAC name. So let's do a condensed structure for this. So we have in the corner CH3, so carbon, 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 right? So we can kind of go by how it doesn't have to be straight. We can go exactly how the line structure is angled. And then we are going to add in all the singular bonds, but we notice on the second and the third is a double bond, right? Let's get double bond. The line angle, actually, let's keep going. So on the edge over here is my CH3, and this is CH3. Now over here, I know there's 3 bonds, so I'm going to add only one more hydrogen in order to allow the carbon to have total of 4 bonds. But the hydrogen is going to be, one is going to be on top and then the other one is going to be on the bottom. How did I know? Well, why couldn't I put the hydrogen down here and then it would have been a different type of an alkene? Well, this zigzag line lets me know that this is a trans alkene. So this is a trans. So already in the IUPAC name, you know you're going to have the word trans. If it was cis, what would the line structure look like? It would have looked like sort of like this, okay, like a bucket. Or it would have looked something like this. Okay, but this is trans, and you see that by the zigzag going up and down. Let's draw the Lewis structure. So we're going to expand it out, and let's keep this line, the zigzag line going. See, double bonded, and so this is might be a little better image of what it looks like in a trans form. What is the molecular formula? We'll count all the carbons. You'll notice there are 4 carbons, and how many hydrogens? 8. All right, so let's go ahead and name this. The longest chain based on this would be 1, 2, 3, 4. So that's butane, or since there is a double bond, it's a butene. Butene. And the carbon in which it starts the double bond is on carbon number 2. Okay, whether you count it from the right or the left, it's still carbon number 2. So it'll be trans-2 butene. Try it for the next one and come back if you got the correct answer. Okay, notice that there's no cis or trans. Remember, cis and trans could only apply if there is a double bond, and if that second one, the double bond is in the middle, not in the end. And because this is in the end, we don't have a cis and trans, okay? And also, the double bond is located on carbon number 1, not carbon number 3, because we need to count it from right to left, because it's going to assign that start of the double bond as 1. So that's higher in priority than if it were to be assigned as 3. So 1 butene. Let's go to the next one. Next one here is a double bond, and it's in the middle, and it's cis and trans can apply to this. Do you know what this one is? This definitely is cis. So I'm going to write the word cis in the end so I know what I'm working with. The cis this area is going to look like a bucket I have mentioned. So like this for the line angle structure. So this carbon is that corner here. This carbon is this corner here. That carbon is that corner, and then I have to put in the CH3. So I'm going to just put it either as a line going out, or we can just put it down. And then same for the other side. Okay, so it kind of looks like a bat here. What about the Lewis structure? Just going to expand it out. So that's my Lewis structure, and the molecular formula. We're going to count how many there are. There are 6. So C6H, let's see, there's 5 here, 10, 12. 12. And then, so what is the name of this? Well, if I were to count it from the left to the right or right to left, the number of the ordering for this will be the same. 1, 2, 3. So it'll be cis 3. And what chain? How long is this chain? 1, 2, 3, 4, 5, 6. So it's hexene. 6 cis 3 hexene. Let's try next one. So look, this one looks really different, right? So that's a triple bond here. So we're working with the alkyne here. Let's start off with the line angle structure, work our way backwards. So there are in this corner, okay? And then that's a corner, okay? And here's another corner, and here's another corner. So I'm going to draw all the dots in each of the corners. And those corners represent how many carbon are present. So here in the very end is a CH3. Then there's a C, triple bonded with another C. So I'm right here now. And then the next one is a CH2. Then next one is CH2, then a CH3. You might wonder, well, how did you know how many hydrogen there would be? It does come with practice. I always know that the ending is going to be CH3 if it's not a double bond. I know the middle guy is always CH2 as long as there's no double bond. I have to kind of think about how many. Remember, they need total of 4 bonds in order to have a stable structure. And I know that if I were to add a H over here on these carbons that already have the triple bonds, it's going over. It's going to have 5 bonds. So that's how I know. It does come with practice. Again, it's not something that I knew automatically on top of my head. It's just something that I've been doing over and over again. Okay, what about the Lewis structure? Lewis structure is just an expanded form of this. Now, if you find that drawing a Lewis structure first is easier for you, then stick with that. It might be easier just because then we could count how many hydrogens are present. Okay, what's the molecular formula? There are 6 carbons here, so C6. Let's count how many hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's H10. What's the IUPAC name? This is an alkyne. So we can number it from 1, 2, 3, 4, 5, 6, or we can name it or count it the other way. 1, 2, 3, 4, 5, 6. Probably best way to go that way because it'll assign the alkyne, the triple bond, as number 2. So that will be 2. Hex INE, hex I. Try for the next one. This is not an alkyne, but it is something that I think you can handle. So here is the key. All right, let's keep going. Go ahead and try this on your own. I'm giving you the IUPAC name. So now you're going to either put it in a condensed or line angle structure. See if you could do it. Come back and check this video. Here is the key. You might have drawn the line structure like this, the line angle structure. Well, the thing is where the triple bond is, those 2 carbon, the one that's next to it actually becomes straight in the real structure. Hence why I have drawn it in this way. Whether this goes up or down, it really doesn't matter. But then this portion over here in the middle where the triple bond is located. So I'm not talking about the triple bond itself, but the one next to it. These 2 carbons are in a line with the one with the triple bond. You could draw the condensed structure, which might be much easier when it comes to the triple bonds.